question again is to find the coordinates of the centroid of the shaded area. So essentially, we got this arc here, and the arc here is a circular arc, and the radius given as 1.5 feet. So that's the radius of the circular arc, and then you have the chord here which bounds the area for which you're looking for the centroids. Now, to do this, we need to actually look at the composite areas, and first thing again we do is we say that C bar is 0, because the whole thing is on the XOY plane, and we are assuming that's symmetric about the Z-axis. Another thing you notice is that y-axis again acts as an axis symmetry, where it divides the area right in the middle, with one part being the mirror image of another part. That means the x should go to 0, because the y-axis is axis of symmetry. So that leaves us with just one coordinate. That's the location of the y coordinate. Okay, so this one is identical to these two areas. I could take the circular arc, combine this here, then from this you subtract the bottom triangle. So this is, let's say, area 1, and that's just the whole sector, which is circular sector, and then you have the triangle at the bottom. This is again 0, x, and y. This is O, x, and y. This angle being 45 degrees, this angle also being 45 degrees. Same thing here, that's 45 degrees, 45 degrees, and this length being 1.5 feet, and then this length being 1.5 feet. So your original area got broken into two separate areas. You have the whole area, which is really a sector out of a circle, and then you have a triangle which is being taken out. So this is going to be positive area, or it will be treated as a positive area, and this is going to be treated as a negative area. Now if I need, let's say, area A1, if I need the area A1, then if you look at a circle, so if you had a circle like this, then in each quadrant the angle at the center is 90, or if you had 1/4 of the circle, the angle was 90. Now you look at here, if you add this whole thing together, the angle is 90 degrees. So it's really 1/4 of a circle. So the area for that should be 1/4 and pi r square, or 1/4 pi r square is 1.5 square, and if you go through the actual calculations, it will be 1.767 feet square. The next thing we need is the location of this centroid. The centroid is SC1 with coordinates x we already know is 0 and y 1 bar. And that's where we need a little bit of help from the. If you have, say, this is x-axis, y-axis, and you have a circular segment like this, and this angle being theta, this angle being theta, then its centroid is around here, and this distance is x bar. Then on the back of the book there is a table. And there is a table at the back of the book, and on the top right corner there is an arc which is very close to this, and the distance given as 2/3 r sine theta over theta. And that's the exact copy from the figure on top, and it's on the right column. Now if I compare this with this diagram, the two diagrams are basically same. The only difference is that in that diagram this whole thing has been rotated by 90 degrees. So the distance there, like if I'm looking at, let's say, y 1 bar, that should be 2/3. Theta is the half of the angle, so that should be pi over 4. Radius is 1.5, and then you have sine, and angle is 45. So that's the actual distance, or when we say the location, or this distance y1 bar. And then all you need is a simple calculation. You get 2/3, 4 over pi, 1.5 is 3 over 2, sine 45 is 1 over root 2. So this cancels this cancels this. You get 4 over pi root 2. And again, if you do go through the actual calculations, this thing comes out to be close to 0.9 feet. So that's what you get for area 1. Now let's look at the area 2. Now that's a triangle, and this part, this is 1.5, that angle is 45, that will be 1.5 sine 45. Same thing is going to be true here, that will be 1.5 sine 45. Then we look at the height, that's going to be 1.5 cosine 45. For area 2, should be 1/2. Height is 1.5 sine 45. Then the base is 2 times of 1.5 sine 45. So that's, okay, this half goes off with this. It's 1.5 and 1.5 and a square. Then you have 1 over root 2 and 1 over root 2. So that's 2.25 divided by 2 or 1.125 feet square. That gives you the actual area for the triangle. Then you need the location of the centroid. Let's say it's at C2. The coordinate for that will be 0 and y2. And for the triangles, that's the height. Then that's y2 bar. That should be 2/3 from this point for the height, and that's 2/3 of 1.5 cosine 45. This is going to get cancelled with this, and you will be left with 707 feet. So that gives you the second coordinate. That means y bar for the whole thing should be a1 plus minus a2. Because the second area is negative, then you're going to have y1 bar a1, y2 bar times minus a2. And all you have to put the numbers in. So we have 0.9 times the first area, which is 1.767, plus 0.707 times the second area, which is a negative area, the 1.125, divided by 1.767 minus 1.125. And if you go through all the calculations, then this should come out to be 1.238 feet.